this section is over solving equations. We'll solve exponential equations first, and then we'll solve logarithmic equations. Since they're inverses, we're going to use logarithms to solve exponentials, and we're going to use exponentials to solve logarithms. If it does not come out perfectly, I want everything to be rounded to 3 decimal places. This will go for the exponentials and for the logarithms. Okay, so when you're looking at an exponential, now if you can get both sides to have the same base, like the same big number, that's the easiest way to solve, because what happens is when they're the same, you just cancel that and you solve the exponent. So I solve x equals x squared minus 2. Well, to solve this, you need quadratic, you get everything on the same side, so I would subtract x. So 0 equals x squared minus x minus 2. Then I would factor, multiply to get negative 2, add to get negative 1, be negative 2 and positive 1. So this factors into x minus 2, x plus 1. So when I set those equal to 0 and solve, I get x equals 2, x equals negative 1. Okay, when you're solving exponentials, you don't really have to worry about checking your answer. When we get to solving logarithms, we'll have to plug things back in because you can't take the log of anything. It has to be a positive number, so you can't take log of 0 or anything negative. Okay, now if you have it as an exponential, but you can't get it on the same side. So the first thing you're going to have to do is you have to get the exponential part by itself. So the first thing we would do on this one, we would divide both sides by 4. So we have 3 to the x equals 5. Okay, then we would take what we have here and we're going to write it like a log. So this would be log 3 of 5 equals x. So we talked about in the last couple sections, how do you convert from exponentials to logs? Using the same formula. Okay, so the same way, how you convert back and forth. So this would be log 3 of 5 equals x. Okay, then we talked about yesterday, how do I solve this? Well, I use the change of base formula. So in my calculator, I would do log 5 divided by log 3, and then I would solve that. Okay, make sure when you're doing it in your calculator, mine has like a parentheses that pops up when I put a log. So when I put log 5, I have to end my parentheses before I can divide by log 3. Okay, we're going to go to 3 decimal places, so this would be x equals 1.465. Okay, so this one, I don't have to divide anything because I have the exponential part by itself. I can't get rid of this part because it's all in the exponent. So after the exponential part by itself, which I do, now we're going to go to write it as a log. So this would be log 2 of 565 equals 3 minus x. Okay, or if you have it the other way, like 3 minus x equals log 2 of 565, it doesn't matter because the whole goal is you're still going to solve for x. Okay, then I don't have x by itself, so what I would have to do, the next step is I'm going to have to subtract 3. So I'm going to move this over there, I have to subtract 3. Now, I can't go inside the log, that's why I have it outside of there. And then you're going to divide by -1 to get x by itself. Alright, when you're solving this, don't try to put it all on your calculator at one time. Figure out what this is first. So to figure that out, I'm going to use my change of base. So I would do log of 565 divided by log 2. Okay, then I would subtract 3. And then after you hit your equal sign, after you subtract 3, then you're going to divide the whole thing by -1. So I get x equals -6.142. Okay, this is just my advice, I would do each step and then hit your equal sign. So I would solve this, hit my equal sign. -3, hit my equal sign. Divide by -1, hit my equal sign. If you try to put everything in your calculator at one time, most of you, or at least I'm this way, I will scribble where I put my parentheses. So if I don't have to worry about that, I can just do each part separately and in my sequential order, then I'm going to be fine. Okay, on this one, the first thing I do is I have to get the exponential part by itself. So I would add 7. So 6 times 2 to the 3x minus 1 plus 16. Divide by 6 times 2 to the 3x minus 1. Okay, that doesn't come out perfectly. I don't care if you leave it as a decimal. Okay, don't round it. So if I'm going to leave it as a fraction, they're both divisible by 2. That's 8/3. If it came out as a perfect decimal, that's fine. I don't want you to round that though. Okay, we're not going to round until we get to the very end. Okay, so we got it like our exponential. So now we're going to write it like a log. So log 2 of 8/3 equals 3x minus 1. And to solve for x, I would add 1. So I have log 2 of 8/3 plus 1 equals 3x. And then I would divide by 3. Okay, same thing. When you're solving, this part is going to come first. So I would do log of 8/3 divided by log 2. And then I'm going to add 1. Then I would divide by 3. Okay, you're going to get 0.805. Okay, I know you're going to see a problem like this in your homework, so I'll make sure we do one of them. Anytime you see something like this, okay, this is actually going to be a factoring problem. How you would get 2x, that would be e times e. Well, anytime you're multiplying something together, if I take the e away, that's going to be a squared. So if I'm looking at this, this would really be x squared minus 3x minus 4. Okay, if I'm just thinking like, I'm taking the e's, so we're going to put the e's back in just a second. So if I factor this, multiply to get negative 4, add to get negative 3, it would be negative 4 and positive 1. So this would be x minus 4, x plus 1. Okay, after I've done that, now I can put my e's back in. I feel like it makes it a little bit easier to factor if you just take your e's away. So this would really be, instead of x, this is e to the x minus 4. And instead of x here, this is e to the x plus 1. Okay, so when I solve the first one. Okay, so the first thing I do is gotta get the exponential part by itself, so I would add 4. So I have e to the x equals 4. Okay, then you want to write like a logarithm. So this would be log e of 4, but instead of writing log e, we do ln of 4 equals x. So then I gotta put this in my calculator. So now I'm gonna do the natural log of 4. So this answer is 1.386. Okay, then I go solve my other one. E to the x plus 1 equals 0. So I would subtract 1 to get the exponential part by itself. Okay, then I write it like a log. This would be log e of negative 1. So log e is the same thing as ln of negative 1 equals x. Okay, well I've already told you you can't take log of a negative. If you tried to put this in your calculator, it's going to give you an error. So this part of my answer does not exist. You can never take the log of 0 or anything below 0. So you can only take the log of positive numbers. So then that's my only answer. Okay, we're going to do one more exponential. So y'all have something similar to this on your homework. I know it looks complicated, but don't make it more complicated than it is. So literally, this part here, the variable's out here, so simplify what's in there. So I would do 0.10 divided by 12, then I would add 1. Okay, so this is 1 and 1 over 120 to the 12t equals 2. Okay, now it's just like the rest of the ones we were doing. It's written as an exponential. So I write it like a log. So this would be log 1 and 1/20 of 2 equals 12t. And then I would divide both sides by 12. Okay, so when I'm solving, I would do my change of base. So this would be log 2 divided by log of 1 and 1/20. And then after I solve that, then I would divide by 12. So log 2 divided by log of 1 and 1 over 120. And then I would divide that answer by 12. That would give me t equals 6.960. Since you're rounding to 3 decimal places, if this is a 0, you need to put the 0 on there. It doesn't get left off. Only time you would leave it off is if the answer came out perfectly. Like 6.9, and that's it. There's no numbers after that. Okay, now we're going to solve logarithmic equations. solving logarithmic equations. First thing you need to do is you need to get the log by itself, which it is on this one. So then you need to write it like an exponential. So since they're inverses, you solve them using each other. So if I want to write this like an exponential, I would need my base to this power. Well, if it's a natural log, that means your base is e. So this would be e to the negative third equals x. Okay, well since x is by itself, all I do now is just plug it in, figure out what e to the negative third is. So this would be x equals 0. Now if I round correctly, this would be 0.50. Okay, so number 8, first thing we need to do is get the log by itself. So I would need to subtract 7. So I have 3 natural log of x equals negative 2. Okay, you have a couple options. You could either divide by the 3, or you could put the 3 on as an exponent because of the properties that we talked about yesterday. Up to you, it's not going to matter because in the end you're going to get the same answer. So I just think it's a little easier if I just go ahead and divide by the number in front. So then I have the natural log of x equals negative 2/3. Okay, then I would write like an exponential. So my base here is e, so this would be e to the negative 2/3 equals x. So that means x would equal 0.513. Okay, make sure on your logs, when you plug them back in, you just need to make sure you're not taking the log of a negative. So if I plug this in, I'd be taking the log of 0.513, that's fine. Okay, alright, so then number 9, excuse me, I have my log by itself kind of with this 6, just like we talked before. I could have divided by the 3 or put it on as an exponent. Same thing with this. You could put that on as an exponent or you could just divide. I think it's easier just to divide. That way you're not doing square roots or cube roots, or in this case you have to do a 6th root. So I'm going to divide by 6. So I have log 3 of 0.5x equals 11/6. Excuse me, I'd write this like an exponential, so this would be 3 to the 11/6 equal 0.5x. Okay, and then to solve for x, I would divide by 0.5. Okay, go ahead and make sure you solve this first before you divide by 0.5. Don't try to do it all in one step on your calculator. So 3 to the 11/6 divided by 0.5. You get 14.988. Okay, we did, I think this was like example number 1 where we had an exponential on both sides. We could cancel out the exponential as long as they're the same. The same is true about logs, but you have to get it to be 1 log and 1 log. So on this one, the first thing we're going to do is we're going to figure out how we're going to make this side be 1 logarithm. Well, yesterday we talked about expanding and condensing. And if there's a minus sign, that means we can combine those logs by dividing. And when you're dividing, the first one always goes on top, the second one goes on bottom. Okay? So then once I have a log on both sides, those logs will just cancel. So then I have x plus 5 equals x minus 1 over x plus 1. And then I can just solve that equation. So to solve it, first thing I do is multiply both sides by the denominator. So I'm going to multiply both sides by x plus 1. So on the right side they cancel. On the left side we're going to actually have to multiply this out. FOIL it out. Or distribute, whatever you want to call it. So then I would have x squared plus 5x plus 1x plus 5 equals x minus 1. So this would be x squared plus 6x plus 5 equals x minus 1. Okay, get it equal to 0, so I would subtract x, and I would add 1. So then I have x squared plus 5x plus 6 equals 0. Okay, then this would factor. Multiply to get 6, add to get 5, would be 2 and 3. So this would be x plus 2, x plus 3. And when I set equal to 0 and solve, I would get negative 2, and I would get negative 3. Okay, I need to plug them in and make sure I'm not taking the log of a negative. So negative 2 plus 5 is 3, that's okay. Alright, but negative 2 minus 1 is negative 3, so that's not going to work. Negative 3 plus 5 is 2, that's okay. But negative 3 minus 1 is negative 4, this isn't going to work. Okay, most of the time you're not going to have both of them cancel. Okay, but if you did, this answer would be no solution. Okay, so on this one, I don't have a log on both sides, but before I can write like an exponential, I need to get these to be combined. So subtracting, same thing before, it means we're going to divide. So this would be log 4 of x divided by x minus 1 equals a half. Okay, then I would write it like an exponential, so like what we did on these other problems right here. So this would be 4 to the half equals x over x minus 1. Okay, and then I would solve. Well, 4 to the half is 2. And then if I want to solve this for x, the first thing I have to do is multiply both sides by x minus 1. So this would be 2x minus 2. Okay, over here they cancel, equals x. And then if I solve for x, I'll just move to the right. So I would subtract 2x. So I have negative 2 equals negative x. Divided by negative 1. X equals 2. And then you make sure it doesn't make anything negative. So I plug it in here, that's fine. 2 minus 1 is 1, so we're good. Okay. That'll get you through the page 254 assignment. Okay, and make sure on those you're only doing every fourth, so you do not have to solve every, it's not evens, it's just every fourth.